Hello, and welcome to our TI Technology webinar hosted by Texas Instruments Australia. We are excited to bring you Trigonometric Functions, Unit 1, Topic 4 from the QCE Mathematical Methods course with a very experienced mathematics teacher and TI technology user, Brian Lannon.
Hello, John. How are you going?
Oh, look at that. He's in already. I love it,
I
Brian.
am. I'm raring to go, mate. All set.
Good man. Okay, well, my name is John Bowman, and I am your host for this event. I teach mathematics to years 7 to 12 students at Lachlan Catholic College in Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. And as you may have heard, I am excited to introduce our panelists tonight, Mr. Brian Lannon. Good evening, Brian.
Good evening again, yes. Oh, you've
How
got
are
some nonsense on the screen about me. Yeah, that sounds right.
Let's talk you up. As you may see, Brian has been teaching for over 40 years. He doesn't look like he has, but he started young in a variety of educational contexts. He has contributed to a range of textbook projects, as well as being co-author of our recent QCE Mathematical Methods Teaching Resource booklet, which we'll be using this evening, and which was released only yesterday, the Specialist Maths TRB. So, Brian, that is it from me on my introduction. I will pass over to you.
Fantastic, thank you. Lovely introduction there. And look, just a spoiler alert: the photo is several years old now, so that explains the youthful look relative to the way things are now. But it was quite exciting to be involved in this writing project. I'm hoping that you see on the shared screen now the front cover of a book. Now, I know you shouldn't judge a book by its cover, but I think it is quite a fairly smart looking cover. The featured calculator, which is one of the approved ones for the QCE, and you may have also been attending the Texas Instruments sponsored Learn, Energize, Connect PD days in Brisbane in late November each year, and I've been a regular presenter at that. I may have seen you there and then. So this is the approved calculator list from QCAR, and you see here the TI-Nspire CX2T. Now, T is one that it does exact arithmetic, so it's quite handy for that. I'll be using an emulator of it, or actually it's not an emulator, it's actually the full-blown software, which if you use any of these Nspire calculators, I highly recommend that you use the software on your whiteboard as you're providing instruction to students while they work along with their handheld units. And that's a partnership that works very well. Also, if you're actually projecting onto a whiteboard, you have the fun of being able to scribble all over things with a white marker, which I use as well, whiteboard marker. Okay, so the table of contents, if these topics look familiar to you, I'm hoping they should, because they are in fact the exact same topics from the QCE Mathematical Methods syllabus. And so we've broken up into the 4 units there. We'll be providing a series of webinars that take you through a sample of one of the topics from each of the units. And tonight's feature is topic 4 from Unit 1, Trigonometric Functions. Now, if you have downloaded the book, or if you've got a hard copy, the activities that we'll be working through are pages 17 through to page 22. And I think John was going to tell you a little later on, if you haven't yet got a copy of this publication, you can download it for free from the Texas Instruments Australia Queensland support page, which I think you've got a slide on that, have you, John?
I have got a slide later on,
yeah.
And I have also just shared the link in the chat window.
Oh, brilliant. Yep. So you could click on it and you see that we're not just making these things up. It really is there. Okay. So this is the start of topic 4, and where we're looking at trigonometric functions. And one of the points from the syllabus was circular measure and radian measure. So I've got a couple of exercises for us here. First of all, constructing an interactive model that displays angles and can be measured in both degrees or radians. So we're looking at introducing students to the concept of radians and what that's all about. And then doing a similar sort of thing in a spreadsheet for angles at 10-degree intervals from 0 through to 360, and seeing what the radian equivalent of that is. And we can look at that both in terms of pi or decimal radians. So you could work through the instructions from the book, and I'm going to do it on the software. And here's one I made earlier. So I've actually, while I was preparing for this lesson, I actually worked through the activities myself just to see if all the instructions I was giving in my own book made sense. But we'll do it. So here we are. These are the final constructions from what we're looking at. But let's just do a brand new one. And here we go. And you may recall that our first instruction was to open up a geometry page. So these are the various applications that we have, and you can see that there's a couple of programming applications, there's widgets, there's data logging. We're mainly going to be concerned with just the first 6 today. Okay, so we'll open
Brian?
Yes, mate.
Somebody just asked, how do they get to that screen if they're already in a document already when they've got the handheld rather than the software?
Yeah, in the handheld, let's just go back to home. If you ever lost anywhere on this, just press the house key. I'm claiming credit for this. I advised the engineers when they were first designing this that I wanted a safe house button. I'm lost, just click home, and there I am. It's a bit like, shall we say, an opening screen on your computer, home screen on your computer. So there's the various applications that can be inserted within a document, or you can commence a new document. There's this scratch pad thing on the left. I would advise avoiding that, and the reason, unless you're just doing quick calculations. The reason I make that advice is that the documents with all its different applications are so much more sweetly integrated of those various applications, the ones that I just mentioned. Whereas Scratchpad, you're just doing a bit of arithmetic, or you're just plotting a graph. That's fairly limited in my view. So to commence a new document, type number 1, new, and you get the list of applications that you're invited to put on your first page. And so we're going to add a geometry application to start off. I know a lot of people like doing that same thing by clicking on the icons here, and that will give you the same sort of result. I prefer to do it the way I just demonstrated, though. The reason being that there's more applications available. Okay, so we're on a geometry application, and you'll notice this bluey color at the top. Each application has a different color about it. But following back through our notes, let's click on here. We were asked to press menu and select shapes and circle, and then using the navigation pad as a mouse, you work through to construct that circle and then define a couple of segments, and then ultimately measure a directed angle. So let's see how all that works. So menu, and where are we? Shapes, circle, and I'll put a point. I'm just going to press enter somewhere in the middle of the screen, and then I'm using my mouse with a computer. The other way to do this is to use the navigation keys or the mouse on your handheld. Okay, so when you've got the got the circle at a reasonable size of the screen, just press escape. And the reason for that is, as we turn on various different tools in our geometry application, those tools remain on until they're switched off. To switch them off, you just press escape, top left on the keypad. Now, what were we doing next? We were going to construct some segments, okay? So go to points and lines and segment. Let's have a look at that. So menu and points and lines, segment. I'm going to do a segment, say from the center of my circle, just out to the right. So there I am there at about 3 o'clock. And let's do another one from there out to, I think it's set at about approximately 30 degrees. Let's, where do you think? About there? That seems pretty good. And remember, escape to switch off that tool. And the next thing we're asked to do is to measure a directed angle. So I go into menu, measurement, and I'll explain why it needs to be directed angle rather than just angle. And then click in order on this point, then our center point, and then the one up on the circumference of our circle. And so the angle that I've just measured, once again, I'll switch off that tool. The angle that I've just measured is 0.5594 radians. I wonder what that might be in degrees. I was reasonably close to my 30 degrees, couple out. Okay. And now if you move your cursor over to that point on the circle, see a little hand appear? Now that's indicating that I can grab this point. In the handheld software, you can see the hand in the middle of the navigation screen. So what you do is you press and hold that, and the hand will close on it. And once that's happened, you can move it, again using that navigation pad, and you see the angle increase. So we're running around a circle here. So straight line, 180 degrees. Watch what happens when I come into the reflex angle, and you can see that it's still measuring the reflex angle rather than the smaller angle in here. Whereas if I had not selected direct angle, but measure just angle, it would be measuring the smallest one. So we can see this in degrees. We can see the same in radians. So it's just a simple model that can be set up to talk to students about, okay, we're familiar with angles in measured in degrees. Well, here's just another way of measuring something that we already know. Yes, John.
Brian, and if people are using the handheld, then they would do the same thing, holding the center of the navipad, or equally, I suppose, if they're hanging over the top of it, they could actually just press Control and then touch the center of the navipad to close that hand.
Yes, that's the Control key in conjunction with that. The instructions that are in the book are actually written for the handheld. And obviously in a presentation such as this, I'm not using the handheld. I could try to do that in a video for you, but it's much more satisfactory to use the software. It is something certainly to be mindful of as the teacher, because even though the software on both devices is pretty much very closely mirrored, there are some subtle differences. So be aware of that when you're teaching, that the students are working along with their handheld units. And of course, the advantage of that is it's very small, it's portable, it's a fairly robust device, and of course they can use it in their exams. But you as the teacher, to demonstrate, I certainly recommend you use the software up on a big screen. Okay, so over the page 18, we're now on a lists and spreadsheets page, and we're going to do the second of our exercises, and that was to construct a spreadsheet that shows angles angle measurements in degrees and radian, and their equivalent radians. So first of all, we're asked to open that list of spreadsheets page. So to insert a new page, a lot of people like going back to the home and then pressing the lists and spreadsheets. As I said, that's not my preferred way. To me, it seems to be going backwards to go back out of the document that I'm already working in. So within the document that I'm in, I go to, can you see plus page as a second function on doc? So I go control and doc, and it brings up that list of applications for me. So here's our lists and spreadsheets. Let's put that in. And the instructions ask us to label column A degrees and column B radians. Here's where a keyboard's handy, isn't it? Working on a handheld, you'd be using the keys down here. I'm using a computer keyboard. Then it says in cell A1, enter the value 0. And in cell A2, enter the value 10. Okay. And now here's an interesting one. It says, navigate the cursor to cell A1 and press Shift. Okay. So that's this. And then followed by the navigation pad down arrow. So that's here. Okay, so I've now got a blue box around these, and it says, said now go to grab the hand, this one here, and then arrow down, keep arrowing down until you're at cell A37. So see that I'm in solid blue around the cells with values, and now I've got this dotted blue, and it's going to be quite interesting what happens. So I go down to cell A37. John, I'm wondering if we have our participants reading along in the book just as I'm doing.
I think it's quite nice they can follow what you're doing on the handheld. I think that somebody's saying that when they try and do it on the handheld, that they can highlight the 2 by doing the shift arrow down and get the 2 highlighted, but then they're struggling then to go from that step there. Yeah,
the tricky bit is doing that hand grab, and it's just holding.
You've got to hold that down for 2
hold
seconds.
That down, yes, as in the instructions here. And
they could also do fill down, couldn't they, if they wanted to?
There is. And when we wrote the book, we're very conscious of a lot of the things that are done, the applications that are done, can be done in a range of ways. And you can see here, I've even made a note of it. There are many different methods for generating a sequence. This is just one of them. So there's a whole range of ways of doing this. You could use fill, or you could use the method that I've just demonstrated, or you could actually define a sequence, because we've got a common difference of 10 in this case. So there's a whole.
The nice thing about this, Brian, is it sort of follows the same logic that Excel follows, and there is that similarity, isn't there, with the Nspire, that it follows a lot of sort of what Word and all the quick link shortcuts, and the same as Excel.
Yes, I know that the engineers in Dallas who designed all this, they followed as closely as possible the Microsoft shortcuts that people are already familiar with. Of the various applications, this lists and spreadsheets is my personal favorite. I quite like using Excel spreadsheet, and you can actually copy and paste to a lot of stuff, like data, of course, directly from an Excel spreadsheet into this one. I quite like doing that. So now we want to set up our conversion. So through the notes back into this. So into the radians, I'm going to define in the formula, see the equals bit here. If I click, this is the formula definition for column B. So it's just underneath the label, and I commence with equals. So it's going to say radians is equal, or is being defined as, well, it's going to be the degrees multiplied by pi and 180, isn't it? So The degrees is a variable already defined. So I click the var tab and then degrees, and then multiply by. Now pi, I could, with a keyboard, just type pi. That's recognized. And you could do that on your keypad here. The other way is to actually find the symbol, the Greek symbol pi, which is in here. So it's under the EE exponential key, just above the comma key, and there's a whole range of symbols there, and there's our pi. And if I want pi divided by 180, there it is. Watch what happens when I press enter. So it's completed that formula all the way down that column B. Note the exact values. If you prefer to see a decimal approximation, you could go into the document settings and change auto to approximate. And there you have the decimal equivalents. Any questions coming in there, John?
When you did that document settings, is there a quick way that you can scroll down between all those boxes?
Using the tab. So when you
yeah.
go in, yep. So it's very fast. It's particularly fast on a computer or on the laptop. But when you go into this, you mean to scroll down to this, we can just click it and then type 7 if you like, which opens it.
Yeah.
And then document settings, type 2. So you can see that they're labeled by numbers, but also to come down to calculation mode, to advance, if you just repeatedly hit the tab key, it moves our cursor down to the one we're looking at.
Just like doing a form.
Yeah, it is. Yeah, filling in online forms and the like. Yep, good comparison. Okay, I think we're up to our next activity. So page 19, if you're following in the book, we're now going to convert angle measurements between degrees and radians. So we'll set up something, and we're just going to do this on the calculator page. Now, because I've already got a few things defined, I suggest we set this up as a new problem. The reason, you've seen that now we've got a couple of pages in our document. When we have names for variables, they are carried from one page to another. So the variable name is linked in, and that's one of the great strengths of this software. But it can also be a hazard if you're developing something new and you don't want to reference a variable that has previously been defined. You can get away from that by just going into the document and inserting a new problem. So it's still it's still within the document that we've got. We're going to add a calculator application. I think, was that right?
Yeah.
Yep. And looking where I am now, page. Yes. Hang on. No, I was going to do. We'll see where we are. Page 19. Yes, calculator application.
And like you said, Brian, if you then click on the variable button, those variables aren't there because you're in a different problem. Is that right?
Correct. So this is now problem number 2, page number 1. Press the var. There's no variables.
Whereas how do you get back to those other pages?
You can navigate up to them using the navigation pad with the 1.2 and click on them. Or the other one is if you go Control and left arrow, goes back to our very first page, Control right arrow, Control right arrow. If you want to see all of the pages in your document, if you go Control and then up arrow, there they all are. A little bit like a PowerPoint presentation.
Beautiful.
I think so. Yeah. Okay. So on this calculator page, we want to convert. The exercise was we got a DMS value 60 degrees, 45 minutes and 15 seconds into radians. And we've said set the document into calculation mode to approximate. Well, we've already done that. And let's give that a go. So it's in approximate, and it suggests you bring up a template in which to enter our angle. Now the template key is just next to the book. The book is the catalogue of all commands. Immediately next to it is, which is a very useful button, of course. Next to it is a template key, and these are a whole lot of templates. You can see the DMS template is actually highlighted because I used this before when I was preparing. There's a fraction template. You can see we've got indices, we've got roots, e raised to a value, log, and here we even have some, these are for hybrid functions here. Also, there's an absolute value template, matrices, all sorts of goodies, summation, etc. This is the one we want here, and our angle was 60 degrees. And I'm just using the arrow keys here, 60 degrees, 45 minutes and 15 seconds. And we want to convert that into radians. Well, you know what? If we just press enter, it's done it. And the reason it did that is because my document page was already in radians. If it was not, like for example, if it was in degrees, I'll just show you what would happen. So there's our angle. See the page is in, or the application is in degrees. If I press enter, what it's done is it's just decimalized it in degrees. I can actually force it to convert into radians by using a command, and we talked about the catalog a moment ago. If I go in here and look for convert to radians, so we've got all of the commands in here. To jump through, if I want to get to radians, if I just type R, it jumps to R in the catalog, and there it is. So if you're ever lost looking for a command and thinking, oh, what menu is that in, just go to the catalog. They're there, and you can see now it's converted our angle, our degrees, minute, second angle measurement into radian measurement. We've even got the little R there, which is quite nice. Okay, we can go the other way. If I had 1.5, I can convert that. If it was 1.5 radians, well, if this was in radians, okay, and then I want to convert that to degrees, then into the catalog. Let's go to that DMS. So hit D for my list of D commands and just arrow down. There it is, DMS. So 1.5 radians is that in degrees, minutes and seconds. So it works both ways.
And I always like misusing that DMS. I'm not sure if it's right or not. If I need students to help with time as well, you know, sometimes, and you'd like them to convert a decimal, but that's a nice little feature as well.
Yes. Just made me think of another one, John. If my angle was not in or radians, like let's say it was in degrees, like the page is in degrees, 1.5, and if I try to convert that to DMS, well, if I just hit enter, which is 1.5, sorry, 1.5 DMS is the command I'm after. Yeah, so what it's doing is it's reading it as degrees because we're in degrees at the moment. So it's saying 1.5 degrees is 1 degree and 30 minutes. The other way to force it is I can say 1.5, force it to be read as a radian value. I can type my 1.5, and remember, you may have noticed before under the pi key, the little R symbol is in here as well. So now it's 1.5 radians, and if I convert that into DMS, that's in the book here, okay, then that we get that same value as before. So as I said, there's all throughout the software, there's a whole range of doing things. People will develop their favorites. We deliberately, in writing of the book, set about trying to do as many different types of things as we could to show the various ways of doing things.
Brian, like you said as well, I think students are much more confident of that than us, is that you can't break this thing. So just giving
That's
things
right.
a go and seeing how it works is a great idea. And we've got that good old undo key, which is a godsend.
Yes, Control Z.
Oh,
It works in software. It works in this as well. Control Z. If you don't like what you've done, okay. Let's move on to the next. We're going to define trigonometric functions from a unit circle. So I think for introduction to trigonometry, particularly with radians, I think the unit circle model is very, very important, rather than just break away from just the triangle. And of course, the key word here is function. Whereas at year 9, trigonometry is a matter of ratios. It's the ratios of side lengths in a right angled triangle. But of course, we know that there's so much more to trigonometry, and it can go greater than an angle of 90 degrees, so you've broken out of your triangle when you do that. So we're now going to insert a graphs page. So this is yet another type of application, and we're going to graph a circle, which of course can't be done as a function editor. It has to be defined as a relation, and we're going to do the relation x squared plus y squared equals 1, which of course is the unit circle. So let's see how that's done. I'm going to go new problem again. So document, remember how this is done, insert a new problem, and we're looking for a graphs application, and there's the function editor by default. But I don't want that. I want relation. So I'm going to go menu, and this is the input type here. The third command, graph entry edit, by default was a function. You can see there's a whole range of lovely things here, but we're going to go with relation. And it's quite simply, you just use your keypad, X and then squared, the plus key, Y, and then squared, equals key, and it equals 1. This is our unit circle. Press enter. Bang, there it is. You'd like to see it a bit larger, wouldn't you? Let's go back to the menu. Let's go to the window zoom in. Let's click in the middle of this. Let's click in the middle of it again. That looks nice. Yep. Let's escape to get out of that tool. Wouldn't you? Yeah. So that sorts that out. Going back to our book, suggests that we now use the geometry, points and lines, and define a few points here. We're going to define a point 1, 2, and 3. Then we're going to do a directed angle. We're going to construct some segments, and we're going to do a directed angle measurement, as you saw in the very first exercise that we did. That was in a geometry application. This is now in a graphs application. So menu and geometry. So even though we're in a graphs application, geometry fits into this as well. And we're going points and lines. How about a point there? How about a point there? How about a point about there?
Brian, you mentioned before that the icon is in the top left-hand area of that screen to show you what you're actually currently in. Is that right? If you hover over the top of it, it also tells you what's going on.
My last point isn't sticking. I'm sorry. I've gone into segment tool there. Sorry, over there. Yes, segment. I must have selected segment tool straight away. I think I did. Yes. So geometry, points and lines, point. So there's the point I'm looking for. Yes, so hovering over it, it'll tell you what it is and then how to use it. Thanks, John. And escape switches it off. Let's now define the segments. Menu, geometry, points and lines, segment. And let's do the segment from here to here. I think I already did do that. And let's do another one from here to here. That's pretty cool. And let's escape to switch off that tool. And now let's do the directed angle measurement as we did before. Remember, it's menu, geometry, measurement, not angle, but directed angle. And we'll click in order on this point, 1, 0, the origin, and the point that's around here. And there's our angle. Switch that off. There's our angle. Now I'm hoping that it got on that point. Yes, it did. So I'm just going to move this out so we can see things a bit better. Now, what's very important and the key thing in a unit circle, as we move this here, and of course it could be in degrees or it could be in radians, but whichever way you look at it, the x coordinate of our point is going to be, that's going to be the cosine of our angle, and the y coordinate, the sine. So wouldn't it be nice to link that through so that we could see it as an angle, or as trigonometric functions of the angle?
Brian,
So, yes,
somebody
John.
just asked,
Yep.
is there a way that you can color that line segment that you just drew up to that point?
There is. So say back here, the attributes for various things, if I go hover over something and control menu, then I can access attributes, and I could change the weight of the line, and somewhere in here is the color. Oh, I'm not finding that. Why? What have I done there, John?
Is it in attributes and then you scroll down to color rather than going, like you're doing the quick keys there, aren't you? Trying to,
Yeah.
so when you're hovering over it, like you were.
I'll jump out of that. Hover over that, over my segment, control menu. Color. It was down here, option B. Yes, line color. And we could make it green. Oh no, we've already got green in there. Let's make it red. Yep. So that can change that. So we've got the green for the angle, red for that segment. And jump out of that. Oops. I've hidden it. Control Z to undo that. Righto. Grab that. Bit around. But what I'm wanting to particularly illustrate here, John, as in the book, is wouldn't it be nice to link that angle through to sine, cosine, and tan and see how it compares to the coordinates? So I'm going to add in, if you see, we're going to do this on a notes application. Now, to do that, and I want it linked to this page. So I don't want to start a new problem. I simply want to add a new application. So I'm going to go Control Document and put in the notes.
And Brian, I think you're one of the first to show me about the maths box, and it's quite a nice feature of the Nspire, isn't it? How you can have this sort of like word page, but actually have this mathematics, this live mathematics happening at the same time.
Yeah, and to have it linked to other applications. It's quite a powerful application in its own right, but I think where the power really comes in is where it's linked to something else, which I'll show in this case. Going back to this case, this is the angle that's critical to everything that's going on, because when we move the angle, move the point on the unit circle, the angle changes. You know, you can talk in terms of degrees or radians, just at the flick of a switch. But we want to be able to link this to something that we can, a variable name that we can then reference in the notes. And here's the magic of how to do this. Hover over it, see how it's gone a little bit grayed. And then if you go Control and Menu, you access a command Store. Look what's happened. It's now saying a variable with a name for us to call it will be defined as this 160.6 degrees. Now, what would you like to call this variable, John?
I'm very old school. I'm still going to go theta, but I'm sure there's much more
Theta?
exciting things you could call it.
Mate, I'm old school as well. Define, and if you remember where those Greek letters were and other things, under the pi key, you may have noticed that theta is in fact one of the options. So now theta, oh, I didn't hit my enter, did I? We're going to have to go back through that. Control, hang on, over that. Control, Menu, Store as theta. Nope, jump out of that. As theta. And I clicked out of it. I've done. I needed to hit enter on
I
that.
think the nice thing as well about the Nspire, like I'm thinking about when I use the 84, is you have to store it as a single letter or a single symbol. Here we could use theta, but you actually could give it an actual word that still becomes a variable. Is that correct?
Yes. Yeah, I could have called it angle. Or I think I would have to call it ANG or ANGL. And the reason for that is ANGLE is one of the reserved words in the software.
Yeah.
Yeah. So there it is, it's done. And you can see, of course, it changes as I move my point on the unit circle. But in the notes application, I'm going to insert what's called a math box. And again, this is all shown in the notes. To insert a math box in a notes application, Control M is the command. So if I hit Control and then M, we get this little application thing surrounded by the red dots here. So let's put in there, it suggests we type sine of an angle. And we actually write SINE. The reason I don't put SIN is a reserved word. SIN is a command within the software, but SINE is something that it doesn't know specifically. And I'm going to define SINE as the sine of theta. Now, the assignment key is that you might notice it's the second function on that template key. So if I go Control and Template, and it's that full colon followed by the equal sign. So it's saying the thing that we're going to call sine is going to be the SIN, I access this through the trig functions menu, of our angle. And close the brackets and enter. So what's happening is sine is the sine of our angle, in this case negative 0.6244. Flick back here, you know what? That's our y coordinate. Well, rounded. I've got it rounded here, but that's the y coordinate. And I wonder what would happen with cosine. So I'm going to do and the assignment.
And I noticed, Brian, as we're typing that in as cosine, it sort of goes from what do you call it, non-italic when you type in cos. I suppose that's because it's assigned, and as soon as you add the extra I, it changes to italic, which means it's free to use.
Ah, interesting. Yes, because the first three letters, COS, it says, hey, I know that. I know what cos is. That's a trig function. But as soon as you say, as soon as I put the I, it's saying, Oh, you tricked me. I thought you meant cos. Well, I kind of did. It's cosine. Yeah, and it's going to be negative 0.781. Let's have a look over here. There we go. And so this is obviously an important connection for the kids to make. You can do tan as well in a similar way. Now, what you may have noticed here, so far in this document, we've got a notes application with this mustardy colour. We've got this graphs application with a sort of an aqua type colour. We've got a calculator application with a grey colour. We've got a lists and spreadsheets with this greeny colour. We've got this darker blue for geometry. So we've got a whole range of different applications here. And that wasn't just by accident. So in the development of the book, we deliberately put in the various layers so that we could show you different applications and different ways of doing things. So it's a little bit like an onion, so to speak, is it not?
Just like Shrek would say, Brian, Shrek with layers.
With layers, yes. I was convinced you were going to say like an ogre, but yeah. But yes, so we have performed this like Shrek with the various layers. Now, how are we going on time there, John? Shall I do the last one?
We're getting a little bit close for time. We may have about another 2-3 minutes if you can squeeze this one through a bit quickly.
Okay, I'll try to smash this faster. So we're now going to investigate the periodicity of trigonometric functions. So we're going to get into seeing that, first of all, in a spreadsheet and then in graphs. And that one's there in data and statistics, a dot plot, and here we have as a function. So let's just quickly have a look at those. So first of all, produce a spreadsheet listing the sine, cos, and tan of angles that are multiples of pi on 6. So let's go for a new problem. So document, insert, problem, and we want the lists and spreadsheets. And our book tells us to type the headings of the columns as ANGL, not angle, because that's a reserved word, SINE, and you've got it, cosine, and tangent. And we're going to get our angles down here. And remember, I said there's a number of ways of doing things. So we're going to do another type of fill down. I'm putting 0 in cell A1, but in cell A2, I'm going to say equals cell A1 plus pi on 6. There's my pi divided by 6. Okay, let's just put this in. You can see that's done it as an approximation. I prefer exact values. Let's go back into our document settings and change this to auto. And here we have this nice little pi on 6. Now, in the next part of our instructions, it says navigate to cell A2 and press Control menu and select Fill. Control menu, select Fill. And then press the arrow down to cell A25. So this is similar to what we did earlier on. And then press Enter. Magic. So there's our angles up to in multiples of pi on 6 up to 4 pi. In other words, 2 revolutions of the circle. Now, we're asked to go to the formula definition for sine and putting equals. And guess what? We're going to take sine from the trig menu. Sine of what? Sine of the variable angle. And there they are. Oh, but it's done that. It's done that in exact. Oh, it's reading my angles as degrees. Let's change this into radians. It's now reading my angles as radians. Can you see what happened there? And we'll do similar things here for cosine. So the cosine column, cosine of the angle. Oops. And the last one, tangent. So that equals the tan of the angle, variable angle. That's pretty cool, including our undefined, the tan of pi on 2, you see. But wouldn't you like to see a scatter plot of these things? So we're now going to put in yet another application type. And I've already told you that my lists and spreadsheets is my favorite, but closely linked to that is the data and statistics, and they work beautifully together. So I'm adding a data and statistics page. Well, it's pretty purple. And so for my explanatory variable or my independent variable, I'm going to click down here and select angle. And for the response variable, I'm going to put the dependent variable sine. Isn't that pretty? And of course, you could independently make more pages of these, but I'll just do it here for cosine, for tangent.
Isn't it cool just how those points just move around? I just think that that animation of that is really nice to see.
Every time kids see this for the first time, they all just go, wow.
Brian, a question that was asked, not so much in these screens, but maybe in say a normal calculator screen, if you've got a variable and you've assigned it, how can you unassign it?
Oh, that's a good question. Let's go back to a calculator. We did have a calculator in there somewhere. So let's say I had, I don't know, John. So the variable John has been defined as 5. Okay, very good. So I could go John squared now, couldn't I?
Ooh. There you go.
There you go. And of course, John's a variable defined here, and you can see it in the var key there. But if we want to get rid of him, not that I'm suggesting that for a moment, my host with the most, but if I do go into the menu and in actions from memory, I can delete a variable. So I hope this doesn't hurt, mate, but I'm going to delete the variable John. Done. So now if I ask for John, or John squared, can't do it.
Yeah, and we can see that it doesn't go, it stays italic as well.
Yes, that's right. Yep. Whereas before it was bold, you notice when I wrote John for John squared. So, yeah, good question. Look, mate, I think we might finish with this one. Somebody asked me before, I would like to see that all connected rather than just as a scatter plot. The way to do that, of course, this little trick isn't in the book, but I just love messing with scatter plots and regressions. So you can see I've gone into the menu. I'll just back that up. I've gone into the menu and gone analyze regression, and here's a whole heap of inbuilt regression models, and the algorithms for these are already built into the software. Now, what sort of model would you like? A linear one or a quadratic, a cubic? You know what I'm thinking? Maybe a sinusoidal model just might work. And there it is. And if you look closely in that, it basically says sine x with the little other little figures of the variations, the error in the actual algorithm, which is very small if you look at those values. Interestingly, if this was cosine, you can also get a sinusoidal model. And if you look at it, it's got our plus pi on 2 in here. That's pretty cool, isn't it? There was one more page, one more activity I was going to illustrate, but this is basically just defining the same sorts of things on a graphs page and setting up a table so you can link a table of values to the graphs of trigonometric functions. But John, I think we're already pretty much on time, so I'm going to hand back to you. And
thank you, Brian. That was great. And I think that showing how all those pages are linked together is really quite powerful. And how I was also looking when they did that graphing one with the notes page, how if you grab that point and move it around, then that notes page also with the maths also changes.
Yes, yeah, the integration of all of the variables across the applications is the great strength, in my view, of the software.
Yeah, fantastic. So as Brian showed at the very start of his session, and also like I'd like to proudly mention again here, we have got a dedicated Queensland TI education page, and it can be found at education.ti.com/AUS/QLD. And if you scroll to the bottom of that page, you'll find the downloadable teacher resources ebooks, like what Brian was using today. And also at the moment, they are available for teachers in a hard copy for the methods, and hopefully around about April, I think, Brian, when they're printed for the specialist as well. So great resources to use, and I know they've been very much in demand. So thank you, David and Peter, for producing those.
And John, there's even more. I've been asked to be a member of the writing team for the same thing for the general mathematics. So we've got
popular man, and rightly so.
Method specialist in general.
So as we begin wrapping things up, if you do have any last minute questions, please try and get those asked in the chat windows. I know that Brian will endeavour to answer them as I finish wrapping things up here. But equally, we can also add them to the planning of future webinars. When you leave this webinar tonight, a brief 4-question survey will automatically appear in your browser. Your feedback guides us as we plan future online events. We listen to your feedback, and so I hope you do share your thoughts in a post-webinar survey. And if you're watching live, in the next 24 hours, you'll be emailed a link to the past PD events, which will include this webinar. I also encourage you all to check out our student, in fact, our teacher for that matter, online courses, and our very own dedicated TI YouTube channel. And that brings us, sadly, on what day are we today? Monday, Brian, isn't it?
Monday, yes. we are in different, John, we're in different time zones, but at this point, it's the same day for us both.
Thank you to Brian for everything you shared with us. Always good to listen to what you have to share. And there's always every time I pick up a little trick. And thank you to those people that contributed with their chat as well. It's really much appreciated. And likely, thank you for all you guys for tuning in. It really is the reason why we do it. And if you would recommend this to your friends and colleagues, and if you're watching it on playback, then I hope you found it useful as well. Brian, thank you for your time tonight.
Thank you.
And that's done, I think.
Fantastic. There's more in the series coming up for the different courses, different units. Thursday this week, there's a Special Maths on matrices, topic 5 matrices. Thursday next week, Maths Methods, Unit 3 this time, topic 5, discrete random variables. So stay tuned, there's more to come.
That's right. And if they go to that TI Queensland page, down the bottom there is a subscribe to our e-newsletter where they'll keep getting updates on all those webinars and things that are also changing in future Learn, Energize, Connect events that you mentioned as well, Brian.
I hope to be at that one again this year too.
Well, me too.
In Brisbane.
All right.
Yes.
Well, thank you very much, everyone. And Brian, thank you very much for your time and sharing all your knowledge about the Nspire.
Terrific. Thanks, John.
Good night.